All right, so we're going to be writing linear equations in slope-intercept form. So we're going to write the equation for example 3. Write the equation that describes each line in slope-intercept form, and they give us a slope and they give us a point. So remember, they want the answer in slope-intercept form. What is slope-intercept form? It is y equals mx plus b, right? Well, what two things do you need for slope-intercept form? Well, you need a slope and a y-intercept, right? Well, we have a slope, that's great, but we don't have a y-intercept. We have a slope and a point. So guess what form you can use when you have a slope and a point? Well, you can use point-slope form, right? So that's what we're going to do. We're going to use point-slope form. Y minus y1 equals m multiplied by the quantity x minus x1. And we have our slope, which is equal to 3. And we have our point. This is going to be our x1. This is going to be our y1. And we're going to substitute those values in to this point-slope equation. Form equation. So we have y minus y1 is 4 equals our slope, which is 3, x minus x1, which is negative 1. Okay, then we're going to simplify this, right? Y minus 4 equals 3 multiplied by the quantity x. Those two negatives become positive 4 or plus 4. And now we just need to go ahead. This is in point slope form, which is perfect, but that's not what the answer is asking for us. The problem is asking that the answer is in slope-intercept form. Well, slope-intercept form, y is by itself. Y is not by itself. So we just need to solve this and use our algebra skills and put this into slope-intercept form. We can totally do that. First, we need to distribute that 3 to both things, right? So I'm just going to rewrite this. Y minus 4 equals 3 times x is 3x, and then 3 times 4 is a positive 12. Perfect. And then we just need to get y by itself. So I'm going to add 4 to both sides, and I end up with y equals 3x, 12 plus 4 is 16. And there's our equation in slope-intercept form. Woohoo, we did it. All right, so we were given a slope and a point. We needed to put it into slope-intercept form, but we didn't have the y-intercept. But that's cool, all right, because we could just put it into point-slope form because we had a point and a slope. We substituted the values in and then just used our algebra skills to isolate y and had it turn into slope-intercept form. Perfect. Let's go ahead and look at the next example, 3b. So for 3b, we're going to be writing linear equations in slope-intercept form. So write the equation that describes a line in slope-intercept form. So slope-intercept form, what two things do you need? Well, you need a slope and a y-intercept. Do we have that? No, we have 2 points. So we don't have a slope and we don't have a y-intercept. All right, but could we figure out a slope? We could using the slope formula. Okay, so we're going to use that. M equals y2 minus y1 equals x2 minus x1. These are like little puzzles, okay? And so then we're going to define our terms. This is x1, y1, x2, y2, and then we just substitute it in, right? We're trying to find the slope. So we're going to go y2, which is 1 minus y1, which is a negative 3, all over x2, which is 4, minus x1, which is 2. All right. These two negatives become positive, so it's 1 plus 3, which is 4, over 4 minus 2, which is 2. 4 divided by 2 is 2. So now we have our slope. Our slope equals 2. Okay? Perfect. So we have a slope. Okay, for slope-intercept, we need a slope and a y-intercept. We have a slope, but we don't have a y-intercept. But we do have a slope and a point. So we could put this into point-slope form, like we did, and then just solve it for y like we did up here, and then we have our equation in slope-intercept form. So that's what we're going to do. All right, so I'm going to go ahead and write down that point-slope form. Y minus y1 equals m multiplied by the quantity x minus x1. My point is m equals 2, and I'm just going to use the same x1, y1, which is already there. So I'm going to go y minus my y1 is negative 3 equals my slope, which is 2, multiplied by the quantity x minus x1 is 2. Okay, so now I just need to simplify. Those two negatives become a positive. And I can distribute this 2, right? 2 times x is 2x. 2 times negative 2 is negative 4. And then I just need to solve and get y by itself. So I'm going to do that by subtracting both sides by negative 3. That cancels. And then boom shakalaka, there we have it. We have slope-intercept form. Negative 4 minus 3 is negative 7. And we have our slope and our y-intercept right there. Awesome. Okay, let's look at the next example here. Check it out, 3C. So this is asking us to write the equation that describes a line in slope-intercept form. Okay, it's giving us slope-intercept form again. That's what we need to do, y equals mx plus b, right? That's what our answer needs to be in. Except this time it's telling us what the x-intercept is and the y-intercept. Now we need to know two things, the slope and the y-intercept. Do we know either of those? No, we don't. Well, we know the y-intercept. Okay, so that's awesome. We know b equals 1. Okay, perfect. So we know b equals 1. But we don't know what the slope. Now, can we figure out the slope if we just have the x-intercept and the y-intercept? We can, because the x-intercept is a point and the y-intercept is a point. So this is the point. What do we always know about the x-intercept? We know that y equals 0, right? So this is the point. X is 1/4 and y is equal to 0. And this is the point. What do we always know about the y-intercept? That x equals 0. So this is really the point. X is 0 and the y is 1. So we have 2 points. So since we have 2 points, what can we do? Yes, we can use that slope formula to figure out what the slope is. And then we'll have the y-intercept, then we can just substitute it in. So let's write down that slope formula. M equals y2 minus y1 all over x2 minus x1. We're going to define our variables. I'm going to call this my x1, this my y1, this my x2, y2. Perfect, perfect. I substitute the values in. y2 is 1 minus y1 is 0 all over my x2, which is 0 minus 1/4. Okay, 1 minus 0 is 1, divided by 0 minus 1/4 is just negative 1/4. Okay, so I have a complex fraction here. I'm going to go ahead and do, I'm going to go old school with this. So 1, this is the same thing as 1 divided by negative 1/4. And whenever you're dividing by fractions, you can always change it to a multiplication problem by multiplying by the reciprocal, which would be the reciprocal of 1/4 would be 4 over 1. So basically, this is just 1 times negative 4, which is negative 4. So that's what the slope is. The slope is equal to negative 4. Perfect. So I have my slope, I have my y-intercept, so I can go ahead and write my equation in slope-intercept form. So y equals mx plus b. My slope is equal to negative 4. My y-intercept is 1, right? And then I just substitute the values in. Y equals negative 4x plus 1. And that's it. That's the equation in slope-intercept form. All right, now it is your turn to check it out. So here's my friend, the pause dragon, reminding you to pause your device. Go ahead and work out, check it out, example 3A. When you get done, press play and we'll talk about it together. All right, see you in a bit. Okay, let's see how you did. So we have to write this in slope-intercept form, right? That's y equals mx plus b. And what are we given? We're given a slope and a point. So what can we do when we have a point and a slope? We can put it into point-slope form, right? Because we have a slope, but we don't have a y-intercept. So we can't just directly put it into slope-intercept form. But because we have a slope and a point, that's just the perfect recipe for point-slope form. Y minus y1 equals m multiplied by the quantity x minus x1. And I realized that you could have solved this a different way like we did back in chapter 4, lesson 6. But for these problems, since we're practicing using the point-slope form, I really want you to practice using the point-slope form, okay? So if you did it a different way, I want you to erase and make sure that you're doing it the same exact way that I'm doing it for these examples. All right, perfect. Let's go ahead and get started. So our slope is equal to 1/3. And then this is our x1, this is our y1. We go ahead and substitute those values in, and we end up with y minus y1 is 1 equals the slope is 1/3 multiplied by the quantity. X minus my x1 is negative 3. Perfect. So then we just need to solve it for y, right? But first I need to simplify this. So y minus 1 equals 1/3 x. Those two negatives become positive, so it's x plus 3. And before I can get this by itself, I need to distribute this 1/3 to both items. So I have y minus 1. 1/3 times x is just 1/3 x. And then 1/3 times 3 is just, that's just 1 because it just cancels each other out, right? Yeah. So it's plus 1. And then we're going to solve for y, so we're going to add 1 to both sides, and we get y equals 1/3 x plus 2, where this is the slope and this is the y-intercept. And it's in beautiful, perfect slope-intercept form. So if you got y equals 1/3 x plus 2, amazing job. Just make sure that you solved it by putting it in the point-slope form and doing it this way, okay? So if you didn't, go ahead and erase and make sure that your notes look exactly like mine. Perfect. Okay, on to the next example. Check it out, example 3B. Okay, I want you to go ahead and try this one on your own. So here's my friend the pause dragon. Remind you to pause your device. Go ahead and work this problem out. When you get done, press play and we'll talk about it together. All right, see you in a bit. Okay, let's see how you did. So we're going to write an equation in slope-intercept form, right? That means you need the slope and the y-intercept to write it. Slope-intercept form is y equals mx plus b. Okay. For a line given through the 2 points. So do we have the slope? No. Do we have the y-intercept? No. Well, what are we going to do? Well, we have 2 points, so we can figure out the slope using the slope formula. M equals y2 minus y1 all over x2 minus x1. I'm going to define my variables. This is my x1, this is my y1, my x2, y2, plug them in. It's 10 minus my y1 is negative 2. x2 is 3 minus x1 is 1. We simplify, those two negatives become positive. We got 10 plus 2, which is 12, all over 3 take away 1, which is 2. 12 divided by 2 is 6. That means our slope is 6. Woohoo! All right, now we have the slope, but we don't have a y-intercept. But what do we have? We have a slope and a point, so we can put it into point-slope form. Woohoo! So you should have done y minus y1 equals m multiplied by the quantity x minus x1. We're going to go ahead and define our variables. So m equals 6, and this is our x1 and our y1, so we're just going to substitute those values in. Perfect. Okay, so y minus my y1 is negative 2 equals my slope is 6. X minus my x1 is 1. And then I just simplify, right? So these two negatives become positive. I end up with y plus 2 equals 6 multiplied by the quantity, x minus 1. All right, so now that I have my equation, I can put it into slope-intercept form by isolating for y, but first I have to use the distributive property. So I'm going to rewrite this. Y plus 2, and then 6 times x is 6x, and then 6 times a negative 1 is negative 6. All right. So now I just need to get y by itself, so I'm going to subtract 2 to both sides, and then we have it. Boom shakalaka. There is our equation in slope-intercept form. So if you got y equals 6x minus 8, yoka denkimashita, you did a wonderful job, and I will see you in a little bit for example 4.